Today's lecture is an introduction to object-oriented programming, and we'll be writing pretty much no code today. And this is just a very abstract lecture. We're not going to be doing anything with code. Just explain some ideas for the next course. So the next course we'll be doing only that, only object-oriented programming. But today I just wanted to give you a taste of what it is, because right now with your knowledge, everything is in the main method, everything is in one place. You don't have a specific structure, and your games are probably around maybe 100, 200, maximum 300 lines of code. But imagine if you had to write an application which is a couple of million lines of code. I have no idea how much League of Legends is, or Dota or something like that, but I would assume a couple of million lines of code. And clearly there has to be a nice way to structure those, right? So what we were doing and what you were doing up to now is very hard, right? And our job from now on is to make everything a little bit easier, a little bit more structured, and so on. So the lecture today is very theoretical, and we'll be doing all of the concepts and more mentioned in this lecture. We'll be doing it in the next course as a full course. So if you don't get anything, if you don't understand it now, it's absolutely fine. When we get to the next course, they'll be explained in quite a bit of depth, with lots of examples and so on. Okay, so what's the idea of the object-oriented programming? Is that you have some hierarchy of your structure. Say that you have you have a game with a dog and a sheep, and they have different properties, they have different methods, they have different actions that they can do, and so on. And the idea is to separate those two structures, not to put them in one place, but they have to be separate and self-contained. So yeah, this is what OOP does. Okay, lecture content. So what is OOP and why use it? Classes and objects, static classes, properties, fields and methods, encapsulation. Number 6, which is OOP structure in C#, is probably the most important part of the lecture, which will be a full example with a similar structure of something that you would have to do if you write a game or an application or anything like that. But we are not going to write any code. I've already done that. I'll just show you a couple of concepts there. Then we have namespaces. This is the thing that I always delete when I make my C# console applications, but from now on we'll be using that, and we'll know what that is, and so on. Okay, finally, enumerations and structs. So we were talking a bit about structs, and I've shown you a couple of examples, I think. So we'll be very briefly mentioning those. And enumerations is something very, very, very simple, which could be helpful to your teamwork projects as well. But it's nothing too complicated, so yeah. Okay, what is object-oriented programming and why use it? So OOP attempts to provide a model for programming based on objects. So the thing that I said, instead of putting everything in one place, just separate your logic. If you have a character from League of Legends, it has to be a whole thing, one separate class, one separate structure. And it doesn't have to do with anything else in the same scope. It doesn't have to do with, I don't know, how big the map is, right? So what we did with Falling Rocks, we put everything in one place. Our dwarf, our board, everything was in one place. But with object-oriented programming, the idea is to separate the logic into different building blocks, like similar to methods, but even more. Okay, objects are an abstract data type with the addition of polymorphism and inheritance. So this sentence is a bit more complicated there, and you'll be able to understand once we go to that point with the specific example. Basically, what this thing says, if I go back a couple of slides, means that I have a structure which is called animal here. It has some properties, probably something like name, age, weight, something like that, and all of these are in here. And once I want to have something which is a bit more specific, like a dog, it's gonna inherit all of the properties and methods of the animal. So even though I don't specifically say that the dog has, you know, weight and age and name, it's gonna get that automatically from animal. So this is pretty much it. If you don't get it now, don't worry. We'll have a nice example for it. Okay, objects are designed in hierarchies. So again, we have animal, we have a dog, maybe we have a couple of specific types of dogs. You know, all of them are structured in a hierarchy. So there is something very abstract at the top. Maybe, you know, I don't know, entity, then creature, then animal. Then you have, you know, a couple of types of animals. Then you have the specific dog, which is a specific breed, and so on. So they're all ordered in hierarchies. Okay, object-oriented programming is meant to make it easy both to reuse existing components. So the thing that I mentioned a bit earlier. So if you have an animal, right, and it has, you know, the name, the weight, and so on, a couple of properties which are common to every single animal, I don't have to write it again for every animal. So say that I have the you know, base on the top, which is animal, and I have their name, weight, and age, and under it I have, you know, 100 types of animals, right? I don't have to give to each one of them, you know, name, weight, and age separately, because I already have it in the base class. So this is reusing existing components. And of course, it'll be very, very easy to extend the functionality. You know, if you want to add a new animal, that is going to be, you know, just a couple of lines of code at max, once you've done, you know, the whole structure of your application. Okay, so OOP will make your code a lot more logical, easy to follow, and self-contained. So again, what we were doing now is, you know, put everything in one place. So if someone has to go through your code, you know, it'll be very, very, very hard for him to understand what's going on. But yeah, if everything is, you know, separated, like similar to methods, but even more, it'll be a lot more easier, you know, for someone to read and extend your code. Okay, classes and objects. A class can be thought of as a skeleton or a template for a specific object. Okay, and an object below there is the specific instance of a class. So that thing that we had. So here I had, you know, class program, which, you know, I always rename something like demo. This is now something different. So imagine that a class is your template or a skeleton of, you know, some real life object. Like let's have the example with an animal. Okay, so I have to have some understanding of how would I like my animal to look. If you remember the bunny, it had a name, it had I don't know, number. Did it have a number? Had a number, and then had health, right? Because I wanted it to have health. But you know, this is just the skeleton. After that, I created a specific bunny which had you know, a specific name like Pesho, and had number 1, and had health like 200. So now this is the specific object, but I have to be able to, you know, tell every object how it is gonna look like. So there has to be something more abstract up there, and that is the class. So a class is the skeleton or a template. Okay, once I have this, you know, template, I can create as many bunnies as I want, and that will be, you know, very, very simple. Just a single line of code, as long as I have done my class properly. Okay, and now that we are talking about classes, which is a bit more abstract structure, they have sets of attributes to hold their state. So once you hear, you know, attributes and state, you have to think about variables. Okay, so attribute, my bunny had attribute health. Okay, and I made that to be an integer, which was, you know, maybe 400 health or something like that. Normally you have to make it a decimal or a double, depending on the accuracy that you want, but in any case, it's going to be a number. Okay, so when we talk about attributes, you think of variables, and how do we model that? So if so, let's make an example of a state. What state can I have? I don't know. Is the bunny running at the moment? Right. This is a state that I can model with a variable. What kind of variable is that gonna be? So is the bunny running? Bool, either true or false. Right. So these are the attributes. Okay. And also we have set of actions. So now that we know that attributes are, variables, what do you think that the actions are gonna be? So they hold behaviors, methods, clearly. So methods normally what they do is change the state. So here you think about methods, and methods generally change the state. Okay, say that we have a bunny wars game, and someone has hit my bunny, and now instead of 400 health, it has 200 health, right? I have to do that in a method with a method, say, decrease bunny health, right? And this is the method which is going to change the attribute or the state. Okay, if I want to make the bunny not running, I have to make a method which is, make bunny stationary and just change that value to false or to true, whatever I want to do. Okay. I already said that. Okay, so let's make a more proper example with a bank. So I have to do this and then this. Okay, so let me just decrease the font a bit. So bank example. And let's talk about, so let's have in this example an account, bank account. And what does an account have as a property or as an attribute? Owner, okay, owner name. What else?
Type.
What do you mean by type?
Like checking savings.
Okay, type. Okay. ID, yes. The most important thing, what do we do with bank accounts? We have, well, amount, there was a better word for it, balance. Yeah, sorry. Kind of forgot it. Okay, that's maybe currency as well. And yeah, let's leave it there. Okay, methods or actions. What can we do? Withdraw. Withdraw, deposit, maybe close account. And let's say that, sorry? Freeze, okay, it's fine. Okay, so now that I've written this, is this a class or an object?
A class.
This is a class. Does anyone else think something different, or who thinks it's an object? Okay, so this is a class because sorry. So this is a class because this just describes the structure of my bank account, right? I don't have a specific account. I don't have that this is Pesho's account, which has 100 levs in it. This is this is the structure. This is the template. And now, if I want to make 2,000 accounts, they are all gonna follow this specific structure, right? So this is a class, and let's make a proper. I want to change the color of that though. So now let's make an object. So what do I have to do here? Owner name, Pesho. Type, savings. ID 0001. Let's just leave it there. Balance. How much do you want Pesho to have? 1 million. Someone is very, very generous. Okay, 1 million. Is that it? Okay, 1 million there. Okay, currency. British pound. Even more generous. Okay. Withdraw. So this is now a method. So withdraw. And let's say amount, deposit amount, and close. So instead of amount, imagine just any number that you want. Close is going to be empty because you don't need to take any parameters there. Freeze also. Okay, so now let's think a bit more about this. So we talked that we should think about variables, okay? But right now I only have name, type, and so on. But these are not computer type properties or attributes. So what data type should special be? String, type, string, or enumeration. Okay. ID. Okay, so this should always be a string. Okay, if I put this a number, 3 zeros, 3 leading zeros are gonna cause problems, and right, so IDs are normally always strings. And right, so let me go on. Balance. Is there a data type number in C#? And the answer is no. So what kind of a number should that be? Decimal. Why decimal? And why not double? Sorry? Decimal is the most accurate data type in C# for calculations where you need to be very precise. And here you need to be, because this is money, right? If someone loses 1 penny, he's going to be very, very angry at you, and that shouldn't happen, right? Okay, then sorry, this is currency. String or enumeration. So in a case where you have to choose between options, enumerations are better. So here, if you have 10 types of savings accounts, then an enumeration is going to be better. But if you have really something which can have all kinds of random characters, then you should make it a string. Okay, so what is going to be the type of amount that I have to withdraw? What data? Decimal again. Deposit, decimal again, and the others we don't get. So now this whole thing in red, let me just circle that in red. Now this is an object, because that's the specific instance of my class, which is with the bank. Okay, is it clear now? Okay, good. Right, animals we did a bit. Games, I don't know, what can we do about games? Okay, how many of you have played either World of Warcraft or Dota? Who hasn't played or hasn't heard at all of neither of those? Warcraft 3, World of Warcraft, Dota 1, Dota 2. Okay, but you're doing something else now, so it's fine. Okay. Okay, so let's make another very, very brief and short example. So let's have the one and only Lich King. Okay. Imagine that you're playing either Dota or League of Legends. I'm sure that there are things very, very similar there. Okay, so what kind of properties or attributes does the Lich King have? So HP, mana, damage, armor, magic resistance, attributes. Okay, so strength, agility. Is that with double L? Single L. Agility and intelligence. Inventory. Sorry? Yeah, speed. Attack speed. Okay, let's say that those are enough as properties. Okay. Right, so now methods. Methods? Deal damage, receive the image, cast, spell, move, die, of course. Sorry? Emote and dance. Okay, not in Dota, but okay. I don't know, weird actions. Okay, something like that. So now this is my class, okay, because I have defined the structure of this hero, the Lich King, and if I want to make an all object, it's gonna be the specific thing that you see in the game that you play with. You know, gains strength, gains mana, increases level. Here we did not say level, which is such a shame. Level. Okay, but now this is my class, and I don't want to write everything here, but now the specific hero which I instantiate with HP 1000 and mana, I don't know, 400, damage 57 to I don't know 64, and then some armor and so on. So this is now is going to be my specific object of type Lich King. Okay, right, no more examples for that. I hope you got it. Okay, so a static class is a specific type of class. Okay, it cannot be instantiated, and the idea here is that you do not have you don't need to have multiple objects of this class. Okay, it's good on its own. You only need to have one. And examples for static classes are math and console. Okay, and I'll show you something here. So do you remember when we did the bunny? It was a struct here, and I said bunny, and I don't know, let's make it I hope that works now. So I can say bunny, my bunny equals new bunny. Okay, so now this my bunny is now the specific object behind the struct or class bunny. Okay, when you work with the console, it's always there, right? You don't have to instantiate it. So I say I don't need to say console current console equals new console, right? And in fact I cannot say that, and the reason is that this class console is static, and this is what you get here if I zoom in. Cannot create an instance of the static class console. So this is something that you only need to have once, right? I don't need to I cannot and I shouldn't be able to make different instances or different objects from my class. So the way I access it is straight by console dot, and then you have the properties, you have the methods, and here we can say that actually C# differentiates. So we have properties with the wrench here, if you see, and methods with a cube. Okay, which visually is, you know, really nice to be able to tell them apart. Okay, so we have the console, and you know, just clear. This is a method. Also, if I want to use the math class, double pi equals math dot pi. Okay, I don't need to make a new math, right, or a new calculator. You only have it there, and it works as you want. So this is the static class. It's nothing special. Just bear in mind that sometimes it's kind of hard to decide when you want to have a static class and when not to. So if someone was to make the console not a static class, they could do it, and you could do it, you know, with new console and use all of the properties that it has and all of the methods and so on. But you have to decide whether there is a point for that, whether, you know, there is any reason to make a couple of these, or you just need one and you are going to use it, you know, as is, just one. Okay, properties, fields, and methods. Okay, this is probably the hardest thing for most people which are new to OOP to understand, the difference between a property and field. So for now, let's assume that they are the same. So this was the health, the mana, and so on. So let's assume for a second or for the next couple of minutes that they're the same. And now after a minute or so, I'll make the difference. So properties and fields are the data members of a class or attributes. Okay, they can be variables or constants. So far we've only done variables, so something like int, but you can easily make a constant in C#. So if I say, int variable equals 5, I can say variable equals 6, and I can print it on the console as well. So I can, say variable, and I would have changed the value, thus variable. Okay. Let me just compile that, but to do that I have to go up here and properties and current selection. So let me click here, Control F5. Where do I have an error? This is probably with the struct, so let me just delete that. Nope, doesn't want to work. Let me delete that as well. Still that doesn't want to work. But I only wanted to put this. Okay, let me just delete that then. How about now? Would you like to work now? Great, 6. Okay, but I can make a constant as well. So constant means that I cannot change the value. So const int constant equals I don't know, 7, and now if I try to change the value, constant equals 5, I should be getting an error. Okay, right, and the error that I have here must be a variable, property, or indexer. Okay, the point is that I cannot do that because it's a constant, and constants are often used, and you should be able to differentiate between variables and constants. Say if I have number of bunny legs, right, that's always going to be 4 unless you are making some kind of evil cruel game. But I would like to say I would like to make this as a constant because I may use it, but I'm not going to change it. So public const int number of bunny legs equals 4. And in fact, when you work with constants, they have to be written in a different way. So if you remember, we did Pascal case and camel case. So this is camel case. The first one is small, and every other is uppercase. If we were doing methods, every word has to be with a capital letter, including the first one. And with constants, you have to be writing them this way: number of bunny legs. Okay, there are different ways to write it. I'm not saying that this is the only one, but this one is very easily differentiable from the rest. And in fact, it's something different, right? It's a constant, and it should not be changed in any way. Okay, let's get back to the properties and fields. Okay, so they can be variables or constants. So these are the data types in my class. Okay, that hold health, mana, and so on. Okay, so now what's the difference between a field and a property? And the thing that I've given here, so these two lines, although they are correct and they're probably the definition of a field and property, they are not as accurate as I want it to be, or not as easy to understand at first. So I'll try to explain it in a different way. But first, let's just see what it says. So fields do not invoke actions. Properties can contain more complex logic. So this is not very explanatory. So let me just try and explain it with something that you know. Right. So let's go to the demo here. All of you probably know list of int. My list equals new list of int, and put the brackets there. or without brackets or with brackets? Okay. So just a question: is this now an object or a class? This is an object because this is a specific instance. So another hint is once you see the word new, this automatically means that you create an object, right? Because a class will be just a definition of your objects. And here with the new, this means that you save enough space for your in the memory for your specific object, so you create it. But anyways, let's get back to the list. Okay, so all of you know how the list works. Who doesn't remember how the list works? Sort of. Okay, so the list is like an array, but you can change the size of this array, and it always doubles its size once you need it. Okay, you don't have to. So if you remember, we did an example with with a normal array, and how would you add one element? You have to create a new array and so on. With the list, you just add an element, and it automatically changes the size of the array if it needs to. Okay, so here we have some properties. Let's have a look. Not that many, so I need to delete this link because it gives me too many methods to look at, so let's just do that. Okay, so we see capacity, we see count, and I believe that those were probably the only two. So we have capacity, we have count, and these are properties now. Okay, I can see them, I can use them, and so on. Fields are normally hidden. Okay, so properties is something that you see, you can access, you can take the value, you can probably change the value. Fields are hidden, meaning that they're used for some kind of internal logic. Okay, maybe you have some algorithm, some complicated algorithm that within this algorithm, within this method, you use maybe a counter, a sum, or iterator, something like I, J, K, maybe some booleans and so on. So these are fields. Okay, these are not visible to the outside world because the outside world doesn't care how it works. Okay, I don't care how the list works, or to a very, very small portion, but I want to be able to use it, and for me to use it, I don't have to know how it's implemented, right? And yeah, so can you tell me now with the list specifically what is gonna be a field inside? So if I ask you what the properties are, you can just press dot, and here we have capacity, count, and I guess that's it. But I want to ask, knowing how the list works, and I hope that but I'll say anyways. So the list resizes twice if it needs to. So if I have 6 elements and I want to add a 7th one, it's gonna double the size, which means make a new array with 12 elements and just copy the rest from the old array back. So knowing how it works, can you tell me a couple of fields or just one field that you know that it's a field and you don't see it and you cannot access it from this here, from the options of the list? Anyone? What is a field in the list? Something that you don't want to see, you don't really care about. Okay, again, what do I do with the list when I want to add an element? So the hint is when I want to add an element, I use something that I don't want anyone else to see, and I only use it for my internal logic. Methods are neither properties nor fields. So fields are data types, so either an integer, a string, an array, something like that. I'll give you a couple of more seconds. Maybe, okay, another hint. Okay, so in this method, which is going to double the size of my array, do I use something which I don't need anyone to know about? That I don't need to show anyone? Okay, to make the copy, I need to have a temporary array, right? So this temporary array I used to make my copies, right? But here you don't see no temporary array, because no one cares how you copy it, how you make it, right? No one cares how it works, but the fact is that it works and you can use it. So this is the idea. Any internal logic that you have, which can use separate variables, arrays, whatever you want, complicated data structures, all of that no one really cares about. They just want to be able to use it, and they don't need access to your counter in method number 5, which you only use once and then you don't use it anymore. So this is the idea. This is the difference between a field and a property. So what you actually see and what you give to the outside world, so like health, mana, and so on, all of these are properties. But if you have some complicated algorithm or some check or something like that, people don't need to see it. Once we start writing classes on our own, the difference is going to become very, very apparent. So now you see that fields do not invoke actions, right? The methods or the actions of my objects, they don't do anything on the fields, right? Field is just a temporary variable that I use, and then after that I just throw away. But for a method, if it says like change HP or make damage or something, I'll be using a property in that method and not a field. Is that clear? Sort of. Right? When I want to take damage, this is going to affect my HP. Right? So the HP is a property that I can access. Right? But inside this method, take HP, I can have some temporary variable, some counter, some sum or something like that. Maybe I want to do the sum of all damage types that I took, and now this is going to be a field that no one really cares about. They just want the final result, which is going to be what is my HP after I take damage. So yeah, okay. So fields do not invoke actions. You just use them and you just throw them away in your class. That's how you want to think about it. Okay, properties can contain more complex logic. They have accessors which are get or set. Okay, so for the HP example, if I want to check what my HP is, I can see, right? And this is the get. So get means that gives you the value. Gives the value. Maybe change to a red. Okay, and with the same logic, set means that you can change the value here. Okay, so every property has either one of these or both. Change the value. Okay, and so now properties can be 3 types. They can be read-only, if I can only get the value but not change it. They can be read and write, when I can get and set the value, or write only, where I can only set the value. Okay, and let's have a look at a couple of examples. So let's see. I have a list, so my list dot count. What do you say? Is that read only, write only, or read and write? Read only. I cannot change the count, right? Count is the number of elements I have. I can't just say, well, instead of having 6 elements which I've already given you and they are there, I cannot tell you to make them 8, right? They have to come from somewhere. So count, if I try to make it something like as a 5, I should be getting an error. And let's see what that error is. Please. Okay, the variable constant is assigned but never used. Okay, and there it is. So let me just click somewhere else and zoom it. Property or indexer list event dot count cannot be assigned to, it is read only. So you get it as an error, right? It's very it's very nice because you have these errors where they tell you exactly what's going on. Okay, but I can use it, right? So I can say int count equals my list dot count, and this now is getting the value. I can do that. So this is read only. Okay, can you think of a property that's both read and write? And I'm sure you've used this specific ones many times in your game. Console dot background color. Okay, this I can set. I can say console color dot blue, or I can also say console dot background color, and that's gonna be fine. So here I'm using it, and here I'm setting it. I can also say console color my color equals console color dot background color. I can do all of that. So this is read. Do I have a mistake? Yes, this should be just console, and now it should work. Okay, so this is read and write. I find it very hard to come up with an example which is write only, and I haven't seen any examples so far. I'm sure that if I go on Google and I search it, I'll find something, but honestly I haven't seen one, and I'm sure that they're very, very rare. Okay, so string dot length, is that read, write, or just write? Only read. It's pretty much the same as count. So we did console dot background color. What do you think of list dot capacity? Okay, the capacity is the total number of elements, including those empty spaces that I have as a buffer. Read and write. In fact, I can say to my list, I can say my list dot capacity equals I don't know, 5 or 54. It doesn't matter. I can set it and I can use it after that. So, okay, so C# allows you to choose the capacity of your list. The same way with the string builder, because we said that those are very, very, very similar in how they work. Okay, I suggest that we have a break before we go on. Okay, so this slide is properties, fields, and methods. We did the properties and we did a couple of examples. Let's go to the next slide, which is methods. So methods manipulate the data of a class. So the data, when I say data, we mean properties or fields or attributes. Methods can be static, which means that so this is very similar to the class. If you don't need to have a method which is different for every different object, but it's the same, something like array.sort. Okay, we can have many different arrays. Okay, this is not a static class. I can have many different arrays, but I have the array.sort method, which I don't need to have, and I actually don't have for every single array. Right? I have it only in the array class as a static method, which means that I don't have to instantiate it with every single object of type array. Okay. They are common for all instances of the class, and you don't need to do them many times. Examples with the console string math, the thing that I said with the array, I'll actually show it to you right now. So we have an array, so int my array equals I don't know, 1 2 3. Okay, and now if I try my array dot sort, it's not there. We don't have it, but I can use the array dot sort, which is a static method now. Okay, because I don't need to have it for every single array. Here I can say my array and so on. You know how to use that. Okay, Constructors are special methods using to assign initial values of the object's fields. Okay, so constructor is something that I used for my bunny. If you remember, I did bunny, number of bunny legs. If you remember, I instantiated it with new bunny, and I said, 200, number 1, and I don't know, name Pesho. Okay, so this thing here is a method which instantiates your object, and you've used that many times. So for example, string text equals new string. So this keyword new means that I'll be creating a new object. I set my space in the memory for my new object. So new string, and here we said character A 20 times, and this created my string variable with the letter A 20 times. And this thing here is a constructor. And if you notice, everywhere there I instantiate a variable with the keyword new, after that I always have these brackets, right? Even though they are empty, which is a bit weird sometimes, especially here, right? We say new list of int and then some weird brackets at the end. And the reason is that this is a method and it's called constructor, so it initializes. So I can do the same thing here, int number equals new int, and I can do that. So this is still a constructor. Okay. Also, can we have different types of constructors? Meaning, can I instantiate an object in many times, or is just one? Is there just one way to instantiate an object? And hint, look at the string. Sorry? There are many ways, so let's have a look. If I open up here, I get the following hint, which is 1 out of 8. So the string can be instantiated, in 8 ways. And if you make a bunny, you probably want to instantiate it in, I don't know, maybe 10, 20, 30 ways, or just 2 ways, or just 1 way. Depends on your application and on your game or the situation. Interestingly enough, the string doesn't have an empty constructor, even though it's created automatically for you. The string doesn't have one, so you cannot just say new string this way. Okay, let me leave it like this. All right. Okay, encapsulation is a concept in object-oriented programming that normally you should follow. I've mentioned it, once when we're talking about the difference between properties and fields, but here I would like to stress on it a little bit more. So encapsulation allows selective hiding of properties and fields to protect the data from accidental corruption. I will get back to that. Let's take a look at the next sentence. So it packs the data object into a single component which can easily be used. And here it comes. So we have this computer, okay? I doubt that you know how the computer works, meaning how all of the parts are joined together, with the bits and assemblies, and with all the electrical chips and stuff like that. I personally don't. I doubt that all of you know, or some of you know exactly and specifically how it works. Okay, but everyone can use it, right? Actually, my grandma has a laptop, and she's really good at it. She downloads films and books on her Kindle and so on. I'm very proud. But yeah, so she can use it, but she has no idea how it works, right? And all of you use it, although very few of you, if at all some, know how to use it. But you do, right? So it's like a capsule with with a medicine, let's say, that you drink and you feel better. It's there, you can use it, right? And it's all fun. But you have no idea what's in it or how it's made, right? So this is encapsulation. The same thing for the remote. Okay, I know that if I press a button, something is gonna happen. If it doesn't, then probably I have to change the batteries. I know that much. But I have no idea how it works. Again, some chips, some signals. I cannot make one on my own, definitely. But yeah, I can use it, and that's the whole point. You give to the end user something that they can use, especially for games, right? They play it, but they have no idea how it's made, right? And I'm sure that now that you have done a couple of games, or you've listened me doing 2 games and 3 next week and so on, that now you start to think how the games that you play are actually made, right? And it turns out to be a lot more complicated than you just know. You put the character there, it can fight and jump and so on. It's a bit more complicated than that. But yeah, in the end, this is one part of encapsulation. The other one is allow selective hiding of properties in fields. When I say hiding, this is what I mentioned for fields, right? People don't need to know how your algorithms work, right? So I can hide it. I can hide my fields. I can hide some of my properties. It's that is fine as well. And I should talk about the accidental corruption and what I mean by that. So if I have the balance, okay, and that's a property because some people can access it, is it going to be read, write only? Read only, right? So this is setting the access level of my property, right? If I made it both, set and get property, then people would be able to make as much money as they want, take them from their bank accounts. But we selectively hide this option for this property to be able to change it, right? So no one can change the balance, and if it was allowed, okay, if someone was allowed to do that, then it would break the whole bank system in the economy and so on. So this is selective hiding. Sometimes you hide it because you don't want to bother users with your logic, but sometimes you really have to hide it because your application is should do so, right? The example with the bank. It's the same with any game. So if I can openly set the health of my hero, then I'll be invulnerable all the time, and there will be no reason for health at all. So yeah, this is encapsulation for you. Okay, so this is probably the most important thing about the lecture. I mean, the others are as well, but you were going to learn them, anyways, how to write them and so on. We'll be talking about the structure, the OOP structure in C#. So interfaces, abstract classes, inheritance, and objects. So if you understand these, then it will be a lot easier for you in the next course. Meaning that it's not hard to type. So everything that I've said here, how to make a property, how to make a field, how to make a method, this is just a matter of learning the syntax, nothing complicated. But if you learn how to actually structure your application, which should be what should be an interface, what should be an abstract class, what is a class, what is an object, when you're able to understand which is what and how does it work with your specific game, then this is the more important thing for the next course. So I'll explain it now. If you don't get it, we will get back to it in the next course with many examples and so on. So what I've created here is a diagram for you to look at, and it's here, and I know from my experience from yesterday that I should use this. Okay. So you probably can't see anything, and I don't blame you, so I'll zoom. Okay, can you see it now? Okay, so now we know what a class is, we know what methods are, we know properties and so on. So this is it. So this is a class, and it's an elephant. Okay, the elephant has tusks, tusk length, something which is very specific to the elephant. Okay, and we have methods. I couldn't think of something very specific for the elephant, so I said, step on something, which is a method. Okay, then we have another class, which is a cat. Okay, and the cat has property fur left on the ground. That's what my cat does all the time. Piles and piles of fur everywhere on my clothes and so on. Methods: eat all day, jump, sleep, something like that. Then we have the dog. I didn't put any properties here, but I'm sure that you can think of some. It can jump and lick owner, say, as methods. Okay, but all of these share something in common, right? And that is that they are mammals. Okay, so if we go up a bit here, we see that we have something which is called an abstract class, okay, which is a mammal. And it has a couple of more things. So we have gender, we have running speed, we have walking speed, and we have a couple of methods which are run and walk. Okay, so why do I put them here, the methods, and I don't put them here? Right? Because I would have to be typing them 3 times, right? I would have to be having down here, I would have to be having the run and the walk and the gender. I would have to be typing them 3 times each, right? This way I make a more abstract class, more abstract structure, which is mammal, and all of my animals below are gonna have these methods and these properties without me having to write anything. Okay, I don't do anything. I just say, well, you're a mammal. You have these things. And now when I say that the elephant is a mammal, then it already has these without me having to write a single line of code. And that's the idea, right? You reuse the code that you've already written, right? You don't repeat yourself, which is very important in programming. Okay, but something weird here. Why did I make this just a normal class? Why do I do it an abstract class? And so you have to ask here, what's the difference between an abstract class and a class? And I'll tell you that an abstract class clearly is more abstract. And the proper explanation for that is that if I tell everyone in the room, imagine a mammal, okay? I'm sure that there will be at least, there are 20 or so people here, there'll be at least 10 different answers, okay? You can have elephants, cats, dogs, hamsters, whatever. Okay, whatever you want. So this is not specific, right? This is very abstract in a sense. So you will be imagining different things. And the big difference is that an abstract class cannot be instantiated because, it's not specific enough. I cannot say new mammal of something, with gender, running speed, walking speed, and so on, because no one is going to know what that is, right? It's not specific. And yes, when you go to C# and you have an abstract class and you try to say new mammal or something, you were going to get an error which says you cannot instantiate an abstract class, and this is it. So it's hidden in the word abstract. If you remember this now, it will be good. So abstract, something that is not specific, so I cannot instantiate it. Okay, let's go on the other side here. We have an eagle. Okay, I read on Wikipedia yesterday that there are 4 basic types of eagles. So let's say that the property is type, and then method: eat a snake. Probably, I don't know if all of them do, but let's assume that they do. Okay, and right, so the eagle is clearly not a mammal. Okay, it's a bird. And I have an abstract class for that as well. So if I say bird to all of you in the room, you are going to imagine something different, right? So this is why this is abstract, which means that I cannot say create a new bird. What does that mean? But if I say new eagle, then that's a bit more specific now, and I know what that means. And again, all of this, which are now 5 properties and 3 methods, my ego already has. Okay, when just with saying that the ego is a bird, I already have these properties and these methods here. And if I have to create 100 types of birds, having to copy paste all of this here is gonna take you a lot of time and is really unnecessary. You would be repeating yourself. You'll be repeating the code, which is bad practice. Okay, And right, so I've made it even more abstract now. So I have birds, I have mammal, and clearly there is something more abstract than that, and this is animal. So I have abstract animal, which is an abstract class, and I have, like, I would assume that all animals have age, some name, maybe the Latin name or something, and then they have weight. I don't think that there is an animal without weight. And let's say that all of them can move, or at least the birds and the mammals. I assume that they that they can do so. Okay, right. Did you get that? The difference between class and abstract class. So we cannot instantiate an abstract class. Okay, but there is something else here that is called an interface, and interfaces are a bit more interesting. So. The interface is not a class. It's not meant to be a class. It's the most abstract of all. And what the interface does is just to give you a skeleton for some feature that you have to implement in your application. So this sounds a bit complicated. So let's have a look at the example that I have. So an interface iJumpable has the following. So it has a property which is jump height and a method jump. Okay, and what this interface does is it tells you that if you have some class which you want to make jumpable so that it can jump, it has to implement those two. So this is just the skeleton. Okay, and here when I say iJumpable here for my cat, I would have to have a property which is jump length, jump height, which I don't have, but it should be there. And I also have the method jump here. Otherwise, I wouldn't be able to compile my program because this is a feature that I want my cat to have. I've described what this feature is, which is jump height and jump, and every class that has this interface has to be able to implement those things. iFlyable clearly has to have the method fly, and I have it here. So where is that fly? There it is, up here. Okay, because my bird is iFlyable, and so is the eagle. Okay, and I have iAnimal, which is just a basic in the interface up there. But if I want to describe a feature, then it has to be done in an interface. Okay, so now a complicated question: what's the difference between an interface and an abstract class? And okay, I think I got what you're saying, but you will tell me if that's correct. So here the cat has two interfaces, and in fact I can have as many interfaces as I want as a part of my class, but I cannot have the cat being both a mammal and a bird, right? This doesn't make sense, right? So a class can inherit from a single abstract class or another class, but it can inherit many interfaces. That's the point. So I have iJumpable, iAnimal, and so yes. Sorry? Why don't we use only interfaces? This is a good point, and this is the next difference between an interface and an abstract class.
Interfaces provide only empty methods.
Yes. So the interface is only the skeleton. We don't have any implementation there. We cannot have any implementation there. So if you try to implement this method move, it's just gonna say, sorry, you can't do that. This is just a skeleton. You can only say you have to have the method move, but I don't tell you what that is. With the abstract classes, this is a huge bonus, right? Because I can have the method run, the method walk. I can have them implemented straight up here, and every single mammal under it is gonna have those, and I don't have to be writing them again. They're absolutely the same thing. I can change them if I want to, but if I don't want to and I want to keep them the same, then that means that I'll have them here. And if I say dog run or cat run or elephant run, they are going to do the same thing, even though they're not here. Run, they are going to be inherited from the abstract class run. And the thing is that abstract classes are very, very useful, because also if you don't want to, you don't have to implement this. So they work as interfaces as well, sort of. So they're like I would like to call it a better interface, if you want to. But that doesn't mean that interfaces are not used or are not good, because here this really describes my my cat in a sense. So it I jumpable, if I have the I drawable interface with a draw method and a sprite or a picture, I can just list many interfaces that I know I have to implement. And once you do that, so once you say that this is I jumpable and I flyable and I drawable, whatever interfaces you have, let's say that there are 7 interfaces with 2 methods each. So there is the control dot, which is very, very cool combination in Visual Studio. That's gonna generate methods and properties for every single interface that you have, and you only have to fill in the gaps, basically, which is very, very nice. Okay, how do we feel about all that? So yes.
I have a question. Why do we use interfaces if we have to define them anyway?
Why do we use interfaces if we
In the classes.
if we don't have to define them if we have to define them in the classes? Okay, so the first thing is, which I said now, is that once you see that your cat, your class, which is 500 lines of code, if you say that it can jump, it can walk, it can be drawn on the screen, and so on, this just makes your from the very first line of your class, this makes it a bit more descriptive. And let's say that you don't really have interfaces, but you want your cat to be drawn. You don't have the I drawable, which has the method draw and the property either sprite or a picture. And let's say that after writing all of the cat and so on, you make your sprite, but you forget the draw method, right? C# is gonna tell you, well, you have the interface I drawable, so you should have this method, so that you don't forget. But there is another reason for it, and I'm afraid that I cannot tell you now, because it will be a bit more confusing. It has to do with the fact that the interfaces are the most abstract thing in C#, and it can be used in a variety of ways. Okay, so let's just have a simple, very quick look at the list. Can I press F12 here? Yeah, okay. Let's see now. So we have list of T. This T is generic, which means that I can put in strings and so on, anything that I want. Okay, so this is now the inheritance here. And I say, well, the list is iList. It's also iCollection. It's a simple iList without the generic. And you can see how many of them are there, quite a lot. And finally we have IEnumerable, which is the most abstract of all. So when you list all of your interfaces, they have to be in an order from least abstract to most abstract. So if you see here list, the next thing is iList, which you would expect to be very similar to the list, in terms of properties and so on. And finally we get to IEnumerable, which I've mentioned. Do you know what that is? So this interface IEnumerable, what kind of a structure does it describe? This is a complicated question. I don't expect any of you to know, or a bit more advanced. It's not complicated at all. So what is enumerable? It's in the word. It can be for each. Okay, enumerable means that you have some, some numbering or some order or some way that you can, tell which one is which. So like a set. If you're a mathematician, then I enumerable is, set for you. So with this I enumerable, the only thing that it says that your class should implement is, it should have the for each implemented somewhere as a method. Okay, and we can have a look at this class here as well. So public list, what is that? So this is clearly a method, but what kind of a method? Constructor, because it has the same name as the class itself, and so on. Okay, so this is a method, this is a method, this is a method, this is a property. You can see here the get and set operators, very simply done, and so on. This count, oh yeah, this is something that we talked about. So the capacity can be get and set, and the count can only be get, so it can only be accessed and not written, and so on. This is an interesting read, let's say, and it's quite big, as you see. A lot of methods and everything here, but you can easily differentiate what is a method and what is a property and so on, and even they are separated. So these two are the only properties for the list, and they are separated by an empty line. And yeah, okay, let's go on because we don't want to be up late on Friday. Okay, any questions about this? Anything else that I can say to make it look better? Is it very different from C++? The C++ experts in the room, not that different. Is it the same? Are there, abstract classes as a thing? Are there interfaces as a thing? Template classes in C#. What is that? I don't know C++, so yeah. Can it have methods implemented in it? Yes. So this is, I would assume from the word template that is an abstract class. Is there so if there is an abstract class in C++, is there a difference between the abstract class and the template class?
In the template, it makes methods based on what input you give, input type integer.
So like an overload.
Yes, it automatically on compilation.
Oh, on runtime. Yes, there is a similar thing. It's called a generic, and you can make a generic class as well.
Yeah.
Here, so the list of T here that we just saw, this is a generic class. So I would assume that this is what you're talking about, but I'm not 100% sure. Yeah. So this list of T can be substituted with anything that you want. It can be a list of bunnies, a list of I don't know. I don't have any other examples rather than bunnies. So.
If you implement this interface, we will have to do the method 100%, or you can skip it like
You can't skip it. So once you have an interface in your class, then you definitely have to have all of the methods and properties in it for it to work. If you don't want to have it, if your class does not have to have this specific method, then probably you shouldn't inherit from the interface anything, right? Because the structure is not the same as the class that you want to make. So does it make sense if I have iFlyable for my bird not to be able to fly, for my specific bird? And if I have such a bird, then probably I don't have to implement the interface, which is iFlyable, which is fine, right? There are birds that can't fly, like penguins. Yeah. So yeah. So for all other birds, I would implement the iFlyable interface, but not for the penguin because it can't fly. Yeah, that's the point. Okay. Any other questions here? More advanced questions here that I probably don't know how to answer. Okay, right. Namespaces. So namespaces in C# are like folders. Okay, if I say namespace, you can think of a folder inside Windows Explorer, and you would be pretty much correct. Okay, so what is a namespace? You've seen and you have used many of them. So this thing here called system is a namespace. Okay, when you say using system, that's a namespace. When you say using system dot collections dot generic, this means that I have a folder, you know, in or a namespace. So I have a folder collections inside the system folder, and inside I have another which is generic. Yes.
Namespace in the namespace.
It's a namespace in the namespace, and I said that is the same thing as a folder inside the folder inside the folder. Is the same thing. And here I have system dot text, and inside this system dot text I have classes. I may have I may have other namespaces and so on. And here with this example with the animals, yes.
So when it's there on the top line we're using system, why doesn't that include everything in the structure below?
It just includes what the classes which are in this specific folder. This is for, because you know, if I say using system and the only thing that I plan to use is this, right? It doesn't make sense for me to load everything else, right? So yeah, it's just whatever class is in the namespace and not like every subfolder. And that'll be very, very slow as well. I mean, especially with the system or some, you know, math class or something which is just huge, right? I don't have to be able. So something like when you play Dota 2 and you want to load your game, and there are 100 or so heroes in there. Does it make sense for me to load every single character, every single creature in there, every single weapon, and so on? It only makes sense to, you know, just load these 10 that I want to have, right? It was not very good example. Sorry? When you pick the hero, yes. Yeah.
Is the using keyword used only during the application or during runtime?
Is the using evaluated at runtime or at compilation time? Is that it? Okay, I don't know. I have no idea. We can check. I mean, but I would assume compilation. I would assume compilation. It makes a lot more sense. But yeah. Anyways, it's still gonna take more time to compile, right? If you have all of that. Okay, so this is the these are the animals that I have here, and you know, with the picture and so on. And I've put them all in a namespace which is intro to OP animals and so on. And I just want to show you how you can do that in another project. So how to use the namespace that you have. So you go to references, right click, add reference, and look for the solution. Left click, OK. This is the same as with the system.numerics that you've used to have your big integer. After that, I have to say using intro to OP animals project. There it is. And now I can start using, say, make an elephant. Okay, elephant, biggie smalls equals new elephant. And bam. It's that. Nothing that, you know, complicated, nothing magical. You just add it to references, and after that you can use it if your project is in a different namespace. So up here, somewhere in program, I should probably be able to say elephant, my elephant, like I have an elephant at home, you know, my elephant equals new elephant. I can say that because they're in the same namespace. So this elephant is now in the scope of my project, and I can access the elephant without having to say using intro to and so on. But if you are in a different project, a different namespace and so on, you have to add the reference to it. And actually this is how you add external libraries as well. Maybe you want to have a special library for the RNG, which is normal because I'm not a fan of the one which is in C#. But you can have a separate one which you can download and then add the reference to it. Just find it either online or browse and so on. And this is how you add your libraries in, and then you can check what they do. Okay. So yeah, these are namespaces. Nothing that complicated. They're just like a folder. If you want to think about it this way, it'll be fine. Okay, and finally, enumerations and structs. So structs, I've already shown you how to work with structs, and in fact, you'll be using them very rarely after this course, probably if you've used it in your games. But after that, you'll be using them not very often. So here, instead of just explaining and making a demo and so on, which I've already done, I'm just gonna say that they're pretty similar to classes. The difference is that structs are value types and classes are reference types. Without getting into too much detail, the integer is a value type and the array of integers is a reference type, right? You remember if we instantiated an array, if I said, let's put it here. So I'll delete that because my program is not going to work because I have not implemented some of my interfaces. But yeah, and I have to delete the reference here for it to work. So yeah, let's create an array. Actually, I have an array, so let's create another array. Int another array equals my array. And you remember that if I change the value of my array, it's not good. It is also gonna change the value of another array, right? Because they point to the same address in the memory, so they are reference types. And this was not the same with with the integers, with the strings, and many other data types. So this is the main difference between structs and classes. So the struct is more like an integer, and classes are more like arrays. If you want to think about it this way, with the way the memory is managed between these two. Okay, so for this specific reason, and without getting into detail, structs are normally used only to store data. Okay, that means that when you have structs, methods in it are gonna be a bit slower. So sorry, the whole structure, if you have methods in it, is going to be a lot slower than if you make it a class. So normally if you do something like geometrical coordinates, just x and y or x, y, z, without any methods in it, just to store the data, then structs are better because they're also faster. But if you have methods, that is going to make them slower. Another example is the dwarf that we have. So we had a dwarf. It has a dwarf x, dwarf y, dwarf symbol, and dwarf color, right, with the game that we made. And it can be a struct because we didn't have any methods in it, right? We were only storing the data of the dwarf. So it will be a perfect candidate for struct. On the other hand, we had some methods which were like draw dwarf, move dwarf, and so on. So I would rather make it a class and put the methods in there. Okay, enumerations are something very, very, very simple. So simply a list of objects under a common name. So here, a good example is days of week. So public and days of week, and that is Monday, Tuesday, Wednesday, Thursday, Friday. Okay, and so what this thing does is that now I can access and make a variable of type days of week. So days of week, current day equals days of week dot Friday, Monday, Thursday, Wednesday, and so on. And I can just say Friday. And right, you can do the same thing with string array or something like that, but this just looks better, right? And if you remember background color, so console color dot, you see that it flash is in the same color, this is also an enumeration, because I simply want to list all of the colors that can be get, and that's all that this is. So with your games, enumerations can actually be very, very useful, but first of all, let's just print it on the console, do something with it. So current day, what do you think is gonna say? Friday. I don't have to do anything to string or anything like that, it simply works. Or it should. Please work. Sometimes you have to ask nicely. Okay, where does that come from? Oh, thank you very much. I was never gonna see this. Okay, Friday. And yeah, that's pretty much it. So when are these useful? In your game specifically. So in your games you have game states. So how many of you don't know what a game state is? Okay, 1%. Don't be shy. Don't be shy. Okay, so game state is something like intro, main menu, then you have game, then you have game over, then you have pause. All of these are different game states. They are implemented differently, and if you're doing a lot of your a lot of your games will have something like that. So something like a boolean is game over, and while it's true, do something, and when you want the game to be over, change it to false, right? And the same thing for pause. Does anyone have pause? Okay, does anyone have intro in their game? Right, so all of those are just different states, and probably you have a boolean saying, are we in the intro, and do something if we are. If not, check something else, right? Have you implemented it this way with the boolean? Pretty much. Okay, but enumerations will be perfect for your case. So if I say public enum game states, and I want to say here I don't know, game over, main game, or just game, or play, maybe play is better. I don't know, pause, maybe what did I say, intro, let's leave it there. Okay, so now these are very good descriptive names without me having to create booleans and change the booleans every time. Now I can just say something like game state, current state equals game state dot. So how do you start your game? Intro. Okay, perfect. So I say it this way, and somewhere below, if someone clicks, or say if click, let's create a method so that I don't get an error. If click game state, current state, thank you, equals game state dot maybe main menu. I don't have it here, so let's just go to play straight away. And also if so now when you do your logic, you can say if current state equals game state dot play, this is gonna be your play logic. Right, simple as that. It's very easy to read, very easy to write as well. I don't do anything complicated here. Just a list of some things which have a common name. In this case, game states, and this makes your code a lot easier to read, a lot easier to manage as well, because I don't have booleans that I have to change all the time. I just have one single state, which is current state, and I just operate with it, and that's all. Right? If you want to make your current games with this game state, if not, then it's fine. You will know for your next game. But yeah, a lot easier to read. Okay, and I did something that I shouldn't have. Can I press escape? I can. Okay. Okay, homework. And before I say that the lecture is finished, I want to explain something about it. So this homework is fully optional. If you don't want to do it, then just don't. If you don't have time, don't do it. It's fine. It's not gonna help you for the current course, but it may be helpful for your next course, at least, to understand the lecture, the many things, the many concepts that I said, just to get them through your head with your own example if possible. Okay, so create a class diagram with the one that I've shown you in a C# console applications. Add at least 50 total, classes, abstract classes, interfaces, properties, methods for your favorite game. Okay, this will also help you think about how it works, how it's structured, and so on. Because I didn't show you how to do that, I will do so now, and it's only gonna take me just a couple of seconds, so maybe a couple of minutes, not seconds. So new project. This is gonna be demo op pimp, I don't know, project. Yes, I would like to save. Alright, so let's say that I want to make a game that's CS. I don't know any classes there, so I don't know, Super Mario. Okay, and instead of writing code, so I don't want you to do that because we haven't learned that. Right click on your project, click on add new item, and up here you have to write class diagram. Okay, and let's call it Super Mario class diagram. Press enter. Okay, and here we have blank space. Okay, but here you have the toolbox, which is very useful. Okay, let's say class. Okay, Super Mario. Okay. That is fine. I'm gonna change this Super Mario game. Alright, because this is the game. And I wanna have a separate class which is just for Super Mario. So where's my, there it is. Okay, so class, do it again, Super Mario. And I would like to have another class which is Luigi. Okay, and I want to have both of them to be under something common, which is character. Sorry, it's okay. I'll change that. I like it. Italians. Okay. So here, now that I have some structure, I can say inheritance. These are both Italians. And here I can right click, add a property which is, I don't know, jump height. Speed. Someone said something probably funny. Alright. Plumbing, is that a property or a method? Property, plumbing, availability, let's say. Are you happy? This is fine. Plumbing, availability. Either true or false. This is gonna be a boolean. Sorry? Okay, number of lives. Add property number of lives. And what else I want to have? I want to have some methods. Jump. Run. I'm not even gonna attempt to write spaghetti, so I'm sorry, this is not a property. Let's delete that. But add method, eat pizza. I can spell that. Okay. Right. Okay, but let's make some. This is weird. Okay. Let's make something specific for Super Mario. So what does he have? A red hat. And this guy has a green hat. maybe only Super Mario can shoot. So method shoot.
So you just hit and when you press Super Mario, say red.
Yeah, no, just this is just an example. Okay. If I have to be very specific, the red hat has to be a class on its own, and it has to be red and green with different sprites. But here, let's just leave it as a property. Okay. Yeah, I can also have interfaces, which is add interface here, and I say jumpable. Sorry. Yeah, sure. Either right click or add them from the toolbox and so on. So jumpable, and here I want to say method jump and the property jump height, and that is fine. And now I can say inheritance. This guy can jump. This guy can jump, and the abstract Italians, they can also jump. I would assume only. Okay, I can make I drawable, so that we have a sprite, we have a draw method, and so on. So right here, in just like a couple of minutes, I've already created probably half the problem. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I did about a third of the homework just in like a minute or two. It's very, very easy. The interesting part is that it actually creates code for you straight up, which is cool. I wouldn't suggest you do it this way normally, but do we have the jumpable? We don't. So control dot. No, it doesn't work. It was some other way. I'll show you in the next course. But yeah, just have a look. This is not the way that we'll do methods. We'll do them the other way around. So first we will write the code, and once we make the class diagram, it's going to be all done for us, which is the reverse way. But for now, just dragging and dropping and trying to know which is an abstract class, which is an interface. So can I create an abstract Italian? Can you imagine just random Italian? Oh, probably, but still an abstract class. So yeah, you have to keep in mind what is a property, what's a method, what's a class, what's an abstract class, what's an interface, and that's gonna help you with your homework, I hope, and with your next course, because the example will be your favorite game. So if your favorite game is like, I don't know, Tetris, then probably 50 will be a bit complicated, but yeah, choose something current maybe. Okay, references, and if you have any questions. Yes, question. Do I have to specify the enumerator every time when I want to access the specific, item? So your question goes down to, do I always have to say game states dot interest? Yes. Otherwise, it's just an empty, Friday in the code. You have to specify. Okay. Okay, that's it. Thank you. And next time we'll be making the snake game, and I'll decide then whether we'll do it with structs, classes, or just in the main method. We'll see. So thanks.